This call is now being recorded.
Okay, salam sejahtera and welcome back. Okay, so today we will continue with the fourth subtopic, 3.4, electromotive force, internal resistor, and potential difference. Okay, electromotive force, or usually we call it EMF. We call it EMF. Okay, so what is the difference between the EMF and also terminal potential difference? Okay, so the difference is EMF. EMF is the energy provided by the source. Okay, so usually the source is our battery. Okay, to each unit charge that flow through the external and also internal resistor. Okay, meaning that EMF is the source, energy provided by the source, usually is from battery. Okay, so this energy, it will flow through external and also internal resistor. Okay. Okay, whereas for a terminal potential difference, terminal meaning that terminal positive and terminal negative. So it's the work done in bringing a unit of discharge from a negative to a positive terminal of the battery through the external resistor. Okay, so meaning that for terminal potential difference, we only measure external resistor. Okay, we only measure external. Okay, so this is what we call terminal potential difference. Okay, and sometimes we will write it as V external. Okay, meaning that it only measure external, external difference between the two terminal. Okay, negative and also positive terminal. Okay, and both also using the same unit. So unit for both also is a volt. Okay, or you can write V. Okay, so we look in detail. Okay, describe the relations between the EMF of the battery and also the potential difference across the battery terminal. Okay, so consider this is a battery. So this is the battery A. A and B is the terminal. A is terminal positive and B is a terminal negative. So consider a circuit consisting of battery that is connected by a wire to an external resistor. Okay, external resistor is the resistor that connected outside the battery. Okay, outside the battery. When the current I flow naturally from the battery, there is an internal drop in potential difference equal to IR. Okay, so usually previously what we learned is the battery is without the internal resistor. Okay, so now for this topic, start from this topic, you need to consider whether there is a internal resistor inside the battery. So for this case, the battery inside there is an internal resistor. So we write as a small letter R. Okay, so EMF we write as this is the symbol for EMF. Okay, so if the current flow through the naturally the battery, there is an internal drop in the potential difference. So the internal drop we write as IR. Okay, so there's the terminal potential difference across the terminal. Okay, we can write it as your EMF. Okay, our EMF is equals to V internal plus V external. Okay, so we can write it as your EMF equals to, because internal is a small letter r, so it's equals to IR plus the external IR. Okay, so we can find in this way. Okay, so V external, sometimes we call it V terminal because they only measure from point A to point B, external. Okay, or we can write it as IR. Okay, of course, this R we are referring is R. Okay, R effective. R effective. Okay, R effective that is stay outside. Effective. Total R total resistor. Okay, total resistor that connected outside. Outside or external from the battery. Okay. Okay, we also have V internal, where V internal, if let's say we have internal resistor, then we need to consider. Okay, so meaning that if let's say initially the battery is the EMF is let's say 9 volt. Okay, it's 9 volt. if let's say the internal resistor is equals to 1 ohm, internal resistor is equals to 1 ohm. So we want to find out what is our V external. If you connect with 1 voltmeter, we need to measure from A to B. Okay, meaning that we measure the external potential difference across A to B. Okay, so we can write in this way, EMF equals to V external, okay, plus V internal. Okay, so meaning that this 9 volt, okay, this 9 volt is provided, okay, is provided, is a source, is the energy provided by the source, by the battery, okay. And V external is the value that we want to measure by using voltmeter. Okay, we want to find what is the value that will appear in our voltmeter. So we don't know, so we write V external, okay, or you can write V terminal also can, okay, you can write EXT or you can write terminal, okay, we are referring to the same thing. And V internal, okay, if there is an internal resistor, so we need to consider IR, okay, because the current will flow through from point terminal, point A, it will flow through the external, and then it will come back to point B, and then go through the external, and then go one round again. Okay, so okay, if let's say the current is 1 ampere, okay, so we substitute 9 equals to V terminal plus I 1 ampere, R internal is 1. So meaning that your V terminal only equals to 8 volt. Okay? Okay. So meaning that even though the battery is 9 volt, but when it come out, when it totally come out, we only can measure 8 volt. Why? Why only 8 volt? Initially it's 9 volt. Initially the source from the battery is 9 volt. But when you measure, when it come out, the voltmeter only show 8 volt. Okay, why? Okay, 1 volt disappear. Okay, 1 volt disappear meaning that 1 volt already dissipated inside the battery. Okay, dia macam hilang lah. So kalau internal and kalau battery itu ada internal resistor di dalam, okay, so when the current flow through, dia akan menyebabkan battery itu jadi panas. Okay, kerana di dalam ada internal resistor. Okay, kerana di dalam sudah ada arus mengalir melalui internal resistor. So 1 volt itu sudah hilang sebagai haba di dalam bateri sendiri. Okay, so bermaksud even though your battery is 9 volt, but when you measure betul-betul, dia hanya 8 volt yang boleh guna untuk external. Okay, hanya 8 volt sahaja. So if you want to measure the external resistor R yang besar itu, okay, you also can measure because we know that your V external is equal to IR. Okay, your V external, okay, ataupun terminal is equal to IR. Okay, IR. Okay, so if let's say just now the potential difference that come out really can use for external is only 8 volt. Okay, so we write 8 volt and I is 1 ampere. So our resistor is actually equal to 8 ohm. Okay, so this is the example. Okay, later I will show you. I will show you in detail. Okay, next. We continue. Okay, for a battery without internal resistor. Okay, if let's say the battery here, you see this battery, the first case, if let's say without internal resistor, meaning that if the battery is 9 volt, okay, if the battery is 9 volt, and 9 volt, there's no internal resistor, okay, maksudnya tak ada yang hilang di dalam battery itulah, okay, or if no current flow in the circuit, maksudnya open circuit lah, macam case ni, ini case ni, switch ni tak tutup okay, even though dia ada internal resistor, tapi kerana switch itu tak tutup, maksudnya tak ada arus, no current will flowing through. Okay, so we can write it as our V external equals to, okay, sometimes I use V external, sometimes I use V terminal. Actually, they are referring to the same thing, okay, equals to our EMF. Okay, why equals to EMF? Okay, for the first case, case yang pertama, battery without internal resistor. Okay, meaning that if let's say without internal resistor, Okay, our EMF will equals to IR. And our IR here, actually, we are referring to V external. Okay, we are referring to V external. Okay, can you understand for this one? Okay, if let's say there's no internal resistor, maksudnya tak ada yang hilang lah. Okay, tak ada energy yang hilang di dalam bateri. Okay, so at that moment, our EMF will equal to our external, okay, potential difference. Okay, case number 2. If there is no current flowing through, meaning that arus itu dia tidak akan mengalir, melalui, okay, dia tidak akan mengalir melalui our resistor. If no current flowing through the resistor, okay, if no current flowing through the resistor, okay, meaning that kita punya internal resistor pun tak ada lah, okay, kerana kita punya EMF equals to IR plus IR. Okay, if there is no current flowing through, okay, if no current flowing through, okay, no current flowing through, current tak ada, bermaksud kita punya EMF masih kekal EMF. Okay, so apa yang dia measure itu adalah masih kita punya V external. Okay, masih lagi nilai yang sama. If you connect with 1 volt, okay, maksudnya apa yang dia measure itu adalah 9 volt balik lah. Kalau kita connect dengan satu voltmeter, because there's no current flowing through, no current. Okay, di sini kita punya I tak ada, no current flowing through. So if no current flowing through, apa yang kita measure itu adalah apa yang kita dapat daripada kita punya bateri. Okay, so bermaksud kalau case ini bermaksud kita punya bateri terus connect dengan satu voltmeter sahaja. Okay, you terus connect with 1 voltmeter. Of course, the voltmeter is from terminal positive to terminal negative, so you will see the measurement is still showing 9 volt. Okay, kerana tak ada arus, even though there is a resistor, internal resistor, kalau dia ada internal resistor, tapi masalahnya internal resistor ini tak ada arus mengalir. Okay, no current, no current flowing through. No current flowing through bermaksud kita punya V internal sama dengan IR tapi I kosong kan. So that's why V internal adalah kosong volt. Okay. So this is the two case where you will get EMF when you measure, you will get back your value EMF. Okay, you will get back 9 volt. Okay, so I will show you. Okay, example. Okay. So this is the circuit okay, where this is the battery, okay, and this is the switch, and then this is the voltmeter. Okay, so voltmeter, actually, what is the function for voltmeter, class? Function for voltmeter actually is to measure V external. Fungsi dia adalah ukur V external, di mana dia adalah ukuran positive terminal, okay, then to the negative terminal. Dia ukur bahagian luaran. Okay, I ini adalah current. This is the current. Okay, so we want to check the current. Okay, so if let's say I straight away battery and then connect with one wire, what happen? Kalau kita check, what happen is tengok battery itu burn. Okay, battery itu sudah burn kerana terlalu panas. Okay, so kalau kita tingkatkan, kalau kita sambungkan, if we can, okay, this one you can try later. I will send you the link. Okay, if let's say we connect with one light bulb ataupun satu resistor. Okay, light bulb actually is one of the resistor. Okay, one of the resistor. Okay, if I connect with one light bulb, what happen? Okay, what happen if I connect with one light bulb? Okay, cikgu tekan. Dia akan slow sikit kerana dia ada external resistor. Okay, dia ada external resistor. Okay, so if you refer here, the voltage that I measure is still 9 volt. Okay, it's still 9 volt. And the current also is still 9 ampere. Meaning that this bulb, okay, bulb ini dia punya berapakah dia punya resistor? Okay, berapakah dia punya resistor? Okay, so we can calculate. Okay, we go back just now. Okay, we go back. Okay, so if EMF equals to I R plus I R, internal and also external. Okay, because there's no external resistor, so ini adalah kosong. Because there's no internal resistor. Tadi cikgu belum set dia kosong dulu. Okay, so meaning that our EMF is 9 volt and our I just now is equals to just now our EM current also equals to 0.9. 0.9. Okay, 0.9. So this one I write 0.9. So your resistor is equals to, okay, resistor is equals to 10 ohm. Meaning resistor yang light bulb itu adalah 10 ohm. Okay, 10 ohm. Okay, next we continue. Okay, here di sini dia ada battery resistance. Battery resistance. Okay, kalau cikgu besarkan dia punya resistance kepada 1 ohm. Okay, you tengok dia punya light bulb, adakah dia lebih cerah ataupun tengok kalau cikgu pergi ke 10 ohm, light bulb dia kecerahan dia kurang. Okay, kecerahan dia kurang. Okay, and then if you refer here, if I increase the battery resistance kepada 10 ohm, ini hanya tinggal 4.5. Okay, hanya tinggal 4.5. Okay, why dia tinggal 4.5? Maksudnya dia sebenarnya 9 volt. Tetapi when we come out, what can we measure only? Okay, only 4.5 volt. Maksudnya 4.5 volt itu sudah hilang. Hilang di mana? Hilang di dalam. Okay, hilang already dissipated inside the battery. And if you see the brightness of our bulb, light bulb, okay, dia adalah kurang terang. Okay, this one will be brighter. Okay, this one will be a dimmer. Okay, so let's just calculate. Okay, case number 2 is EMF equals to IR plus internal and also external. Okay, so if EMF initially is 9 volt, because the battery, the power supply, the battery, the energy provided by the source is 9 volt. Okay, and the current. Okay, current just now we use the ammeter to measure is 0.45. 0.45. Okay, is equals to 0.45. Okay, and our external, we don't know. This is the way we want to find external. Plus, internal resistor is just now I shift to 10 ohm. Okay, so if you calculate, you take out your calculator to calculate. Okay, what is our external resistor? Okay, please calculate what is our external resistor. Okay, so 9 over 0.45. Okay, 9 over 0.45, you will get 20 equals to R plus 10. Okay, plus 10. So meaning that your resistor is equals to 10 ohm. Must still use the same. Still the same. Okay, still the same. Okay, so why our V external only equals to 4.5? Because if you calculate IR, okay, equals to IR, and your I only left 0.45. Okay, but your resistor still the same, 10 ohm, because we are using the same light bulb. That's why you will only get 4.5 volt for external. Okay, 4.5. If you compare with just now, our V here is V external. Okay, V external is equals to 9 volt. Okay, that's why V external 9 volt, and if you compare with 4.5, kalau kita tengok balik, okay, of course the light okay, the potential difference across the light bulb, of course dia kurang lah. Okay, tadi kalau I just balik ini is without the internal resistor. So current yang melalui light bulb ini adalah current dia adalah 0.9. Okay, and then the potential difference across the light bulb is 9 volt. Okay, tapi kalau kita besarkan, tengok semakin besar dia punya internal resistor, dia punya light bulb semakin kurang terang. Okay, why? Because the voltage across the light bulb only 4.5. Only 4.5. Okay, boleh faham? Okay, so you can try lah, you can play around. Okay, so if let's say, just now the question say, when we will get EMF equals to our V external when the battery is without internal resistor. This is the case where the battery is without internal resistor. Kalau kita ambil internal resistor jadikan kosong di sini tengok if we the battery resistor if we change to 0, so your V you will go back our EMF. Okay, case number 2 is if let's say we want there's no current flowing through the circuit. Okay, case number 2 is okay, now if let's say I adjust, there is an internal resistor 10 ohm. There is an internal resistor. Tapi kalau cikgu bukakan switch, if I open the switch, okay, it will go back to 9 volt. Okay, if I close the switch, it will go back to 4.5. Okay, why? Because if you connect, there's a current flowing through the internal resistor inside the battery. Okay, maksudnya 4.5 itu sudah hilang di dalam battery. Okay, tapi kalau cikgu buka switch itu, okay, if I open the switch, current tak mengalir. Okay, current even though kita ada charge tapi current tak mengalir. Cikgu change. Okay, macam ini. Current tak mengalir when there's no current flowing through the battery or through the internal resistor. Maksudnya apa yang kita measure ini adalah memang itu adalah EMF kita. Maksudnya kita hanya measure battery sahajalah. Okay, apa yang kita measure itu kita hanya measure battery. Okay, I change back. Okay, so similar like this case. If let's say this is a battery, we can connect straight away. Okay, we can connect straight away. So you will get 9 volt. Okay, maksudnya you terus measure battery itu pun boleh. Okay, ini maksudnya tak ada no complete circuit ataupun open circuit. Okay, so if you connect directly to the voltage voltmeter, you will get 9 volt as well. Okay, so this is a case. Okay, if let's say I connect, I don't want light bulb. Okay, I don't want light bulb. Okay, I don't want light bulb. Okay, maybe I change the resistor. If I change the resistor also can. Okay, if you want to change the resistor also can. Okay, kalau you nak change to resistor. Okay, so maybe I want to change to 2 resistor connected. Okay, I want to change to 2 resistor. Okay, 1 resistor first. 1 resistor first. Okay, so this resistor is equals to 10 ohm. 10 ohm. Okay. Okay, so you can adjust. You can adjust. So I delete. Okay, you can adjust. This is 10 ohm. 10 ohm. So if this one you can adjust to 120 ohm. If you see, when I adjust the color line of the resistor already changed. Okay, because each line represent different color. Okay, now if let's say I change to 10 ohm. 10 ohm. So what happened is 10 ohm. Okay, similar like just now the light bulb. Okay, if we switch off. Okay, so you will get 0.45. Okay, if let's say I connect another resistor. Okay, so this resistor also equals to this resistor also equals to 10 ohm. Okay, so now become 2 10 ohm. 2 10 ohm, and internal resistor I also still okay, internal resistor maybe I also change to 10 ohm lah. Okay, usually not greater, very small only. Okay, so just now if let's say without this resistor, okay, if let's say just now only 1 resistor, kalau tadi kan macam kita punya light bulb jugalah. Okay, ataupun cikgu tukar light bulb lah bagi you nampak clear sikit. I take off this one. Okay, I cancel off this one because I want to let you see the light bulb. Actually, light bulb and the resistor similar. Okay, I connect light bulb. Okay, so that you can see the brightness. You can see the brightness of the light bulb. Okay. Okay, so if let's say there's no internal resistor, light bulb itu terang sikit. Okay, terang sikit. So if let's say I increase the internal resistor, maksud potential difference across the external, maksudnya dia sudah kurang lah. Okay, kalau cikgu buangkan internal resistor, dia masih 9 volt. So maksudnya meaning that 9 volt it will distribute to these two light bulb. But if let's say I increase the internal resistor, kalau cikgu ingat yang keluar itu hanya 6 volt. Okay, hanya 6 volt sahaja. Okay, hanya 6 volt. Okay, so if we calculate again, okay, just now only only if let's say only one light bulb. Okay, if let's say just now only one light bulb, our V external is equals to 4.5. Okay, only one light bulb is equals to 4.5. Okay, now if let's say we have two light bulb, okay, so our EMF is equals to I, of course, IR here, this R is the effective R, external, okay, plus IR. Okay, so EMF is 9 volt, the source is still 9 volt. The current now, it changed to, okay, current now, okay, maybe we can calculate the current as 0.3. Okay, we check, see whether correct or not. So the current is the value that we want to find. Okay, R, of course, R here, we are referring to, because we have two light bulbs, so it's 10 plus 10 for external. Okay, plus R is the internal resistor. Then just now I changed to 10. Okay, so we can factorize out I to 30. Okay, so meaning that our I is equals to 9 over 30. Okay, so if you press the calculator, 9 over 30, you will get 0.3 ampere. Okay, we check correct or not. Kita check correct or not. Betul lah, 0.3 ya. Okay, 0.3. Okay, so we get 0.3. Okay, this one can understand. Okay, if let's say I increase the battery ya, battery kalau tak mau 9 volt, cikgu keluarkan. Nampak tak? If you adjust my battery 100, you see keterangan dia. Okay, lebih cerah. If let's say increase the voltage, okay, macam inilah. This is 33, 45. So you can play around the value. Okay, you can play around the value. Okay, so this is later you need to try to develop your own circuit. Okay, try to play around. Okay, so we will continue. We will continue with our 3.4. Okay, internal resistor. Okay, page 64. Okay, state the factor that influence the internal resistor. So internal resistor is defined as the resistor of the chemical inside the battery, okay, between the poles, and is given by, okay, so we can write our internal resistor, okay, because our V internal equals to IR. Okay, V internal equals to IR. So our internal resistor, we can write it as R equals to V internal over I. Okay. So the value of internal resistor depends on the type of the material that we use. Okay, it depends on the type of the chemical materials. Okay, and the symbol of the our internal our EMF and also internal resistor, kita boleh lukis macam ni ya. Okay, where our EMF, okay, so you can draw in this method. Either you draw internal resistor on your left, okay, or you can write your internal resistor on your right. Okay, either one. So dua-dua pun sama sahajalah. Okay, you can write either on your right hand side or on your left hand side. Okay, so this is the symbol. The current in the circuit is maximum when the terminal of the cell is short circuit, okay, or no external resistor connected together. Okay. Okay, when we will get current maximum? When you want to get current maximum, okay, meaning that your R must equals to 0. Okay, so we refer back just now. Okay, how you can get I maximum? When I maximum, meaning that there is totally, okay, this one I change back on the battery. I change back to 10 volt. Okay, 10 volt. Okay, and then this light bulb I already take out. If no external resistor, okay, why my circuit cannot move? Because see, there's disconnected. So I connect back. Okay, when I connect back, what you can see is this one is 0. Okay, what you can see is our current. Okay, if let's say still, okay, our current at that moment is the maximum, is equals to 1 ampere. Okay, is equals to 1 ampere. Okay, so why our V terminal equals to 0? Why our V terminal equals to 0? Because the current flowing through the battery already dissipated inside the battery. So when it come out, there's no potential difference across the terminal, okay, for external. So this is what it means. Okay, so at that moment, kita tengok okay, when our R equals to 0, okay, kita tengok balik okay, when R equals to 0, meaning that your V external equals to IR, even though there's a current flowing through, but because of R equals to 0, so that's why your V EMF equals to V external plus V internal. Okay, or we can write at EMF equals to IR plus IR. Okay, IR plus I internal. Okay, I write again. Okay, IR plus I internal. So if let's say there's no external resistor, meaning that your V will equals to 0. Okay, meaning that your voltmeter will show 0. Okay, so at that moment, your EMF 9 volt will equals to I R. Okay, so if let's say your R just now, what is the value? The external? 10 ohm, 10 ohm. Okay, if let's say your internal is also 10 ohm, okay, so meaning that your current will equal to 0.9 ampere at that moment. I changed to 9. Okay, just now is actually the battery is 9 volt. Okay, it's 9 volt. So if you refer back, the current is 0.9. So at that moment, you will get the maximum current. Okay, if not believe, you try again. If let's say we connect one resistor, okay, ataupun one light bulb. Okay, if you connect with one light bulb, okay, if you connect with one light bulb, okay, not connect. If you connect with one light bulb, one resistor, you see the value becomes 0.45. Okay, the value becomes 0.45. Okay, if the resistor increase, then the value of course will be less than 0.9. If let's say there's no resistor, even though I connect, it will go back to 0.9. Okay, you will go back to 0.9. Okay, so later you can play around lah. Okay, so we go to combinations of the cell. Okay, combination of the cell. Okay, so here our cell, it can connected in series or in parallel. Okay, so if let's say connected in series, okay, if two cells connected in series, the total EMF, okay, and the total internal resistor, we can just add on. Okay, kita tambah sahaja. Okay, kita tambah sahaja. Okay, positive, negative, negative, and then positive, and then negative. This one is connected in series. If the cell is connected in parallel, parallel meaning that positive with positive. Okay, our negative connected with negative. So if let's say in this case, meaning that because it's parallel, so our EMF for both also same. Okay, E1 equals to E2. But our resistor, because it's parallel, so we need to use 1 over R1 plus 1 over R2. Okay, if I say this is connected in series and also parallel. Okay, if one cell EMF, okay, is turned around in opposite to the other, so our E total will equal to EMF minus E2, E1 minus E2. Okay, meaning that if let's say your battery, okay, just now is positive, negative, then positive, negative. Okay, so this one E total, you can write E1 plus E2. Okay, but if the battery is turned around, right, the question said if let's say turn around, meaning that positive, negative, connect with negative, positive, positive, negative, and then negative, positive. Okay, so your E total, you must write it as E1 minus E2. Okay, because they connected in opposite direction. Okay, in opposite direction. But the internal resistor, okay, remains unchanged. Remain unchanged because your internal resistor can on your left hand side or on your right hand side. So there's no changes. There's no changes. Okay, so our R still the same. Okay, for both case still the same. R total is equal to R1 plus R2 for both case. Okay, next. Okay, if the different cells are connected in parallel, okay, there is no simple formula for the total EMF. Okay, and the total internal resistor where Kirchhoff law later we will learn. Okay, in the next subtopic, 3.6, 3.6, the Kirchhoff law. Later we will use Kirchhoff law to determine if let's say there's a lot of cells connected together. Okay, so we need to use Kirchhoff law to determine. Okay, so we go to the example 7. Okay, example 7 is a battery with the EMF. So this is the EMF, the battery, the source, and the internal resistor inside is 6 ohm. The potential difference across the terminal. So this is determine the potential when it's supplying with the current. Okay, so don't worry, you just write the equations only where we write our EMF is equal to V, okay, is equal to V external plus V internal. Okay, where our EMF is 9 volt. Okay, V external ataupun V terminal is the value that we want to find, meaning that the value that show in the voltmeter. Okay, plus V internal. Okay, V internal, because we have internal resistor and we have the current, so we can use IR. Okay, internal is equal to IR. So it's equal to 0.5. And then your internal resistor is equal to 6. Okay, so V external or V terminal is equal to 9 minus 3. You will get 6 volt. Okay, you will get 6 volt. Okay, meaning that this 6 volt will show in our voltmeter. Okay, will show in our voltmeter. Okay, so meaning that the source initially is 9 volt. Source initially is 9 volt. Tetapi apa yang boleh guna yang betul-betul keluar hanya 6 volt sahaja. Okay, hanya 6 volt. Why? Because 3 volt already dissipated, hilang di dalam bateri sendiri. Okay, hilang sebagai apa? Hilang sebagai haba lah. Okay, hilang sebagai haba. So the maximum current which the battery could supply. Okay, you want to get a maximum current. Remember, you want to get a maximum current. Your R external must equal to 0. Still remember? Okay, you must adjust your external resistor equals to 0. So our EMF equals to V external, okay, plus V internal. Okay, so V external is 9 volt. EMF is 9 volt. V external is equal to IR. V internal is equal to I small letter r. So because you want to get maximum current, so your R must equal to 0. Okay, so your I maximum will equal to 9 over internal resistor 6. Okay, so the value that you get is equal to 1.5 ampere. Okay, so that's all for our class. Okay, example number 8 is your homework. This is your homework. Okay, and remember, later I will send you the link. You can try to solve this question. You can try to play around with the circuit. Okay, thank you, class, and see you in the next subtopic. Okay, bye-bye.